Hello everyone, ChemC is back again. After since a long time, Let's Be Chemist has been newly addressed as ChemC. So welcome to the new video, and we're going to talk something really advanced, the molecules of life, which is quite important to life. Furthermore, if you wanted to elaborate it furthermore, we're going to talk about organic chemistry. So, organic chemistry is the most complex and most interesting section of chemistry that you all will be learning. And I will be even learning. So, what is organic chemistry? Organic chemistries have functional groups. Okay. And as you can see the upcoming topics we are going to talk about. And we will be going through some quizzes so that you will be understanding. So let's see what is chemistry. Organic chemistry. Organic chemistry is the basic structure or basic study of common carbon-based compounds. Examples including methane, CH4. So there are many types, isn't it? As we know, there are many types. So you need to understand how these really affect. We're going to learn a lot today, so you all might be needing to concentrate a bit. And this lesson is quite advanced. Furthermore, now we've understood what is organic chemistry. So, well, why is organic chemistry important? So, it specifically allows us to create new materials within unique properties, like in that case, plastics. So, as we can see now, we're going to learn about plastics and synthetic fibers. So it can also play a major or a crucial role in the development of new medicines, or many drugs are made, and mainly many drugs are made from organic compounds. Now, in short of organic compounds, it can cause a crucial effect to the environment too. Let's talk about it later. Now, we're going to talk about functional groups and about basic organic chemistry. As I said, organic chemistry is the study of carbon-based compounds, which are in all living organisms and many man-made materials. So, at its core, organic chemistry is all about understanding how atoms and molecules interact with each other to form new compounds, isn't it? So, atoms, we can simplify. You can go to one of my previous videos on atoms, elements, and compounds. We're going to, in that video that was on 2022, that was 1 year before, you can see about what is an atom and what is an element, so on. If I want to revise about it, atoms are building blocks of matter, and they are made up of protons, neutrons, and electrons. I have specifically done an advanced video on that, so now all of these hold a chemical bond. Now, organic chemistry, we're going to talk about specifically covalent bonds. Now, in organic chemistry, mostly common ones are covalent bonds, where two atoms share electrons. Okay. Now, organic compounds, like as I said, organic chemistry is based on carbon-based ones. So in that case, organic compounds, carbon should be playing a major role in its compounds, right? So there are many types of organic compound can be categorized by the presence of hydroxyl groups, carbon to an carbon atom. So now we're going to talk about alcohols, alkanes, alkenes. These words might be new to you, but this is quite common if you all concentrate on this. Alcohols are commonly used as solvents and antiseptics and fuels. And carboxylic acids are organic compounds that contain both carboxylic group and hydroxide group. These compounds are commonly found in food and pharmaceuticals. And now you're going to talk about functional groups. Functional groups are specific atoms or groups of atoms within a molecule, which determine the chemical and the physical property of the molecule. So there are many types of functional groups. These common functional groups include hydroxides, carbonyls, carboxyls, amino groups, hydroxyls, and many other stuff. If we talk about hydroxyl groups, they contain oxygen and hydrogen atoms and are found in alcohols. Carbonyl groups are carbon double bonded to an oxygen. Carboxyl groups contain carbon double bond with oxygen, also an hydroxyl group, and are found in carboxylic acids. Now we talk about alkanes. Alkanes are a type of organic compounds that contains an entirely single bonded carbon atoms. So if we draw the structure of CH4, now you might be wondering how this formula came. We're going to talk about it later on in another video. So we're going to talk about the types. So there are numbering system in organic chemistry, like meth, eth, prop, but, then pent, hep, hex, hept, oct, so on. So this comes under the meth. So C1H4. You might be wondering the common formula how to make alkanes. So you can make the alkane formula by using this CN H2N plus 1. So you're going to determine this N by whether it's meth, eth, prop, but, pent, etc. These structures ones we are going to talk about it later on. Alkanes normally have chains, longer carbon chains, and they tend to have a higher boiling point and melting points than short chains. Let's see about alkenes. Alkenes are a type of hydrocarbons that contain carbon double bond. Now, this is called a single bond, and this is called double bond, and this is called triple bond. Now, we need to determine the structure of CH4. This is an alkane, not an alkene. So, if we see clearly, carbon has 4. It's going to be like that, and that. And hydrogen is going to share 1 each. And now this should be remembered by all. This one represents 1. And if it goes like this, and this, it represents this. So it should be double bond. If it's so on, now a pair of electrons represent one of these. As you can see, it only represents 1. Now, if there are 2 in this case, like this, it will be represented in this way. So here, if we format this, it's going to be like C1 single bond, single bond again, and a single bond. Got it? So as you can see, single bond, double bond, and triple bond. Single bond is weak, double bond is stronger, triple bond is much more stronger than double bond and single bond. And in that case, stronger means they have higher melting points according to their number of bonds. Alcohols. So now we talked about alkenes now. So high alkenes have a specific one. So you can highlight these if you want, take the notes. Alkenes are type of alkenes are type of hydrocarbons that contain carbon double bond. You can take them as short notes. One important alkenes, they are able to undergo addition reactions. This means they can add to the double bond. Alkenes are always starting material of production of plastics, if they ask questions, and synthetic rubber. You may take notes of these. Let's go to the next slide, and we're going to talk about alcohols. So alcohols are quite interesting. Alcohols are class of organic compounds. Now, if you see clearly, alcohols contain OH group. This is the alcohol's functional group. This only acts as an alcohol. Remember. You can take these notes down. Alcohols are a class of organic compounds that contains hydroxyl group attached to a carbon atom. They're commonly used as solvents, disinfectants, and antiseptics. Alcohols are found in beer, wine, sprites, etc. The properties of alcohols depend on the size and the structure, carbon chain, as well as number of positions of carboxyl groups. Methanol, ethanol are two commonly. You can note them down. So you can see the terms meth, eth, common. Methene, ethene, ethane, methane. So you can take these as notes. So you can see something really common between them, right? You can take this as a small short note for the next upcoming lesson. Meth is 1, and then oct is 8. Rest will be continuous. Meth, eth, prop, but, f, x, oct, so. Now, the following shows, the following list shows and list of them, so you can refer them. So as you can see, this is the list. This can really help you in developing in structural compounds. So meth represents 1, eth represents 2, prop represents 3, so on. So now we can see meth here and meth here. So normally if you're naming, you can easily identify if it's meth or eth or prop or but, etc. by the first few letters of the compound in an organic compound. Let's go and let's see what we have next. Structural examples for alkanes. So you can take them down. As I said before, there are some points here you need to note them down. The general formula of alkanes is CnH2n plus 2. Simplest alkane is methane CH4, which I discussed before. For examples of, now we are going to listen to about isomers later on in one of these slides. You can take them notes. You can take notes. Structure examples for alkenes. Ethene, methane, propene, you need to understand them. I've listed before some of them. Structural examples for alcohols. So if you don't understand, you can rewind this video and you can slow the video down if you all want to and get the points down. And if you all want further discussions, you can probably on captions for more clarity. And you can take short notes from the highlighting, which is being constantly done by me. And you can see the screen annotations for further references. Now, structural examples for alcohols. Hydroxyl is the functional group. General formula is, I'll give the general formula later for that. Use this as the general formula for it. This would be much easy. H2N plus 1. Use this as the general formula. If you go electron, OH minus is functional group. You can underline this. Examples: methanol, ethanol. So there are many examples. We can talk about isomers now. Isomers are molecules that have the same molecular formula but different structures. Instead, like they have different structures. Same thing but different structures. That's it you all need to know for today. Isomers and structural drawings will be done on a different video later on in the day. So in conclusion, organic chemistry is a fascinating field that studies chemistry of carbon-based compounds. And that's it for today, and have a great day.